Hello and welcome to the report on building a chatbot with sentiment analysis. So, amongst all kinds of chatbots has been implemented so far, we specifically select the text generation chatbots for social purpose in order to get a better understanding for our project. And after a thorough investigation on the papers listed here, we find that a seg-to-seg model is the mainstream of building such kinds of chatbots. So before getting everything started, let us hear from a specialist for a seg-to-seg model.
Hi, this is Team 5. Our target is to build a sentiment analysis chatbot. First, let me introduce the data processing progress. In this case, our team selected several datasets, include Twitter movie subtitles. We tried all of them, and due to the limitation of time, we finally selected the Twitter lower ASCII corpus as our final dataset. The data cleansing steps in this step, the first thing we need to do is to split the text by line and remove characters which are not words, digits, or common punctuation. Then replace the abbreviation with non-abbreviation, like replace won't to will not. And finally, we need to add beginning and ending signal for each sentence. In this case, we add STA in front of the sentence and END at the end of the sentence. Then we need to convert the words to vectors. Firstly, tokenize the text and build the vocabulary dictionary. In this dataset, we found more than 11,000 unique words tokens, and we just used 10,000 vocabulary and replaced the extra words with something. After building the vocabulary dictionary, we can generate words to index the array. So our training data was created. And because our target is to build a sentiment analysis chatbot, we need to add sentiment weight. We introduced two sentiment analysis packages. One is AWS Comprehend, and the other is weather sentiment. For implementing sentiment analysis, we introduced the sentiment score as weights, just multiplied by context array. So, as for modeling, first, we use global embedding matrix to compress the word vector to 100 dimensions. And the body of the model, we selected sequence to sequence. This is the outline of the model body. As you can see, there are two input layers. One is context and the other is answers. After embedding the input layers, merge them and then pass to a dense layer. The output layer is a dense with the same size of our vocabulary size. This model was trained without sentiment weight for 100 epochs. The first 30 epochs output is like this. As you can see, the robot is not even intelligent. It can only speak like I'm not a person, or I'm not even sleepy. But after 100 apples, it can speak out some complicated with multi-word sentence, though it maybe not even makes any sense. And we made a conversation test. The robot performance, I think it is not bad. In fact,
So I will talk about using AWS Comprehend sentiment analysis to our chatbot. And here's how the output of AWS Comprehend sentiment analysis looks like. It's in JSON file. And you can see that here's 4 types of scores, which are positive, negative, neutral, and mixed. And finally, there's a sentiment section that tells you the final sentiment that AWS gives you. However, we only concerning about the positive score. So we set the positive sentiments equals 1, and all the rest of them are 0. And then we multiply the positive score to the question word vector before training. And here's the result for 50 epochs. And you can see we are starting to get some reasonable sentence, not just start and end. And here's our prediction for the first 50 input. Here's the confusion matrix. You can see that most of non-positive sentence we can easily predict by our model. However, none of the positive sentiment we predict correctly. And then I did another data, which is our paired question and answers. And now we have 48, 62, 6 alliance, and 11, 24, and 4 unique word tokens, which are a little bit lesser than the previous one. And here's the confusion matrix. We can see that our non-positive sentiment still performing well, and we have 3 more correct sentiment for non-positive. However, the positive sentiment are still missing.
Okay, so as for evaluation finalizing step, actually we have put a lot of thought on it, and finally we agreed on using human evaluation to measure the quality of responses generated from the chatbot. Although it is the most expensive way to evaluate the response, we guess we can't afford like 50 response per model, and the reliability was much more better than other matrices. However, we can still define a new set of labels that cares only about whether there is a value rather than zero on the certain label. With the help of such a set of labels, we can easily define or evaluate how well the model is sensing the positivity or negativity inside the expression, and how does it express on those expressions. Okay, we can see from the metrics the outcome is pretty accurate, and sentiment score is also pretty accurate. Okay, so inside the training and testing marathon, inside this assignment, we're gaining confidence in our model because the more data we feed it, or the more epochs we train it, the more like human our chatbot talks. And as for further enhancement, we may deploy some reinforced learning to this chatbot, but let us conclude our reports for now. Thanks for watching.